Ladies and gentlemen, greetings once again. We are continuing with our CS3420 tutorial sessions. Today, we just want to build on what we started in tutorial 1 on MIPS assembly programming by looking at a simple addition program. The three main things that we want to do in this session is to show how um, we can develop a model or emphasize the importance of model development in assembly programming, and then just build on the implementation side of the model, um, how you map your variables basically in your model to um, registers in your assembly implementation, the concept of system calls, and the importance of making sure that your code is nicely documented using clear commands. And then finally, um, testing our implementation using single step execution or a complete run. So basically, what we want to do is to um, develop a program that adds two numbers uh, that um, have been supplied by the user. So remember what we said is you want to make sure that your code is nicely commented. You specify the offer, okay, nicely, and you want to specify the purpose. So this is a simple addition program in MIPS assembly. Um, then we can specify the date. Remember, this is December 2020, and we can um, be contacted um, if someone has questions on um, the code that we would have written. Um, so that is the the starting command that we should always make sure that we include in our code. Um, and then we said um, we want to speak about the importance of um, so this will be simple addition, okay, dot asm, and we make sure that here we save it in basically all file types. So that's fine. So we said we want to start with the importance of developing a model. Remember, we are programming in assembly, and which is a bit low level. And in class, what we emphasize is that you want to develop a high level implementation of the program that you want to implement in assembly. You can use a high level language such as a C++ or C, or I mean any high level modeling tool that you are comfortable with. However, the most easier one in this context basically is just to write um, a snippet C++ code. So in C++, what we would want to do um, is basically say we want to do everything in main. So we'll have variables for the two numbers that we are going to prompt the user for, and also variable to store the sum. And then what we'll do is we will say enter the first number, and then we read that number from the user, and then we say enter the second number, um, then we read that number from the user, and then we compute the sum basically using the two numbers. And you want to do what you want to print the sum. Then want to print the sum and then return to the operating system. Okay, so this is our model in C++, and you want to make sure that you also comment it because um, it's not part of your assembly um, program. It's simply your description of what you are intending to do in assembly. So you comment it nicely, um, and you can even um, highlight here that this is um, a high a high level uh, model. Okay, that's your high level model, which is fine. Now that we are done with the model, what we want to do is to now move to the actual translation of your high level model into a assembly program. So the best thing to do is to do it stepwise. Okay. Before we do anything else, we know that our assembly program will have two sections, being your um, data section and your text segment as well. Remember the data segment, that's where you maybe you declare uh, allocate memory, or you um, like you create string values that you use as part of your implementation, and then inside the text, you want to make sure that you have your main um, um, section. And, okay, so what you want to do is now try and look at your model. Of course, we know that um, what we have done so far, we have simply um, declared a main section. Okay, we have done this. We have not implemented the body of our main, which actually includes the functionality of our program. And let's say we want to start by doing line 9. Okay, line 9 basically declares variables x, y, sum, and um, in assembly, XY sum will be what? There will be registers basically. And this therefore takes us to another important aspect that we need to always consider carefully when we go into implementation, which is the idea of register mapping. Okay, that is, you want to specify clearly how your variables are mapped to specific registers in your assembly implementation. So you remember we said your MIPS processor has 32 registers, and there are these temporary registers, the T registers, which are used for storing values temporarily um, inside your code section. So what you can do is, okay, let's say this is register variable what the mapping. Okay, so that's fine. So you want to say x maps to what? uh, Maybe x can map to t naught. Then you want to say y maps to what? You can choose to map it to t1. And then you also want to say sum will map to register t3. Okay, why the T registers and not the A or the V? It's because the T registers are meant to store temporary values basically within um, your procedures. Okay, the A ones are used for passing arguments between functions, and the V ones as well. So you want to make sure that you use registers appropriately. Okay, So that's our register mapping, um, which we have decided upon, and we will follow follow that as we implement our program here. So we already have a plan in mind that register T0, register T1, T3 will store XY sum, um, respectively. And we don't need to declare those variables in assembly. They are there already as registers. What we can do is to look at line number 10, okay, which actually prints a message on the screen, enter X. 12 prints a message, 15 also prints a message. What we can do is that we can declare um, data um, data values, string values. So call it prompt X. Okay, it's of type what? It's of type um, ASCII. Um, it's of type ASCII. Then we give it a value of what? Enter X accordingly. Then we create another one, prompt Y. Then it's ASCII type. Then this one is enter Y. That's fine. Then we say result. Um, uh, let's call it res result message. Okay. So it's ASCII as well. The message there is the sum is with a column. So we have created those string values that we will use within our implementation. Now, what we want to do is to write a code that's going to prompt a user for X. Okay, it's very important when you write your code that you include your comments and you make your comments as clear as possible. So prompt for X, and now we say, okay, how do we write a message on the screen in assembly? You will remember the concept of what system calls that we spoke about yesterday. You can even refer to I mean the the code that we wrote yesterday and say, okay, um, system call code 4 is for printing strings on the string on the screen, and then you put the 4 inside v naught, okay, as your argument. Then you also put the message that you want to output on the screen inside register a naught as the argument as well, and then you do the system call, right? So you can even just copy that code without wasting much time, and then you put it here. Okay, um, it's just that here the message that you want to print on the screen as this one is prompt X. Okay, so you don't need to now repeat all of this because you have already um, written a nice block comment over there, prompt user for X. um, it will print the message on the screen, and what you now want to do is to read X from keyboard, okay, and store in what, and register. Okay, uh, this is basically you doing this cnx, okay, cin basically X. Okay, so what do you want to do again is you can go to, okay, we didn't do something like that. You can go to the slides, go to the slides or to the video, and then you check the um, system call code for reading integers. um, okay, so you go to that table over there, um, Here is our table. Um, Read integer. Okay. It's what? Um, it's 5. So what we want to do is we will say load integer into register v naught. You put what? 5. And then what you do once you have loaded the integer, you do what? You perform a system call. Okay. You perform a system call, and then your result is going to be stored inside um, v naught. Okay. So you do system call, it will read, and then you want to say move into what? Into T naught, which is your X register according to your mapping. You are moving a value from V naught, which has been read from the keyboard. Okay. Now you want to do the same thing for Y as well. So you can simply copy that code. Uh, so this will be problem user for Y, and this will be read Y from keyboard and store in rec. Okay. You just have to make sure that here you are reading, you are displaying the correct message, and then here you are reading Y into the appropriate register. Okay. Um, what you might want to do as you write your assembly, you might want to um, run it even before it's complete, just to make sure that things are developing fine. So what you want to do is maybe include your exit um, system call, which is here. It's a call code what? 10. Okay, so you put inside v naught 10, and then you so this one is as the exit program. Okay, basically return 0. Okay. um, so let's make sure that our code looks neat. So we can open our qt. This is the console. We can open um, align the console nicely so that it doesn't obstruct us. Then we load our code, um, which we call simple addition. Okay. It loads. Normally, if there are syntax errors inside your code, as you load your code into the simulator will show you an error and actually indicate the line where there's a problem. So here we go. We have our code. We can either do the complete run, okay, where you press run and then it says enter X, you supply 2, then you press enter, it says enter Y, you supply 4, and then you say what? Enter, right? The important thing is to look at the registers on the left tag, okay? Um, this is your T naught, you put 2 into it. This is your T1, you put 4 into it. And then after that, uh, you you basically exit, okay? You're done executing. Meaning what you now want to do is to implement the last section of your program, which is um, line line 14. Okay, so you can say um, add um, x and y and store sum in rec. Okay, so this is basically you doing sum is equal to x plus y. Okay, so you, for you to add, you call the add instruction. You're storing the result inside what? Inside register. We said it's T3. Ideally, let's make it T2. Okay, it's going to stay into T2. The result from adding T naught and also adding T1. We have the result over there, and we can actually go back to the simulator, reinitialize, um, load the code, simple addition, make sure that we run the console, and then we enter X, 4, we enter Y, 8, and then you can see that we have performed the addition operation here. We have added 4 and 8. When we press enter, we have stored the result inside register T2. Okay, let's see. Okay, I think there's a bit of a problem here, because it gets to, and then it exits. Okay, um, and the reason is because we put our art instruction after exiting. So we need to locate it nicely, remove it here, and put it here before we exit. Reinitialize our simulator accordingly. Um, Load the program, um, run the program, enter X, 12, enter Y, 7. Okay, then we can actually go to register T2 here and see that the sum of um, T naught, which is 12C in hexadecimal, has been, let's, okay, has been added to 7 to give us 19 in decimal, right? So this is how simple it is. The importance of making sure that you develop your model nicely, your model works, and then you incrementally implement your model and make sure that you comment your code. This code is not complete, but I'm going to leave the last part, basically the last bit for you to do, which is outputting the result on the screen, which says the sum is, and then you output the sum. So guys, please do it, and um, let me know via WhatsApp or email, or chat chat room on Tutor if you encounter any problems. All right.